Hello everyone, welcome to our YouTube channel Science of. In this video, we are going to discuss about atmospheric dispersion. When we talk about atmospheric dispersion, it consists of two words. One is atmospheric, another is dispersion. Atmospheric is related to our atmosphere and dispersion is related to scattering of pollutant so that they will not get accumulated in a particular location. To understand atmospheric dispersion, we can take the example of emission of gases from stack, or we can take example of fugitive emission from pipe and vents, exhaust emissions, plume from fires, so on and so forth. And to understand atmospheric dispersion, there are so many models such as Gaussian model, numerical model, statistical model, empirical model, and physical model. But out of all this model, Gaussian model is the most significant one. It is the most significant one, but it is not perfectly correct because it has number of assumptions. The first assumption is that there is no variation in wind speed and direction between source and receptor. Suppose a man is the receptor and stack is the source. If the concentration of the pollutant is like 5 mg per liter and wind speed is like 5 meter per second and direction is eastward, so between the source and receptor the wind speed will remain as it is, that is 5 meter per second, and direction would be eastward. So there would be no variation in wind speed and direction between the source and receptor. This is the first assumption. Second assumption is that suppose sulfur dioxide concentration in the atmosphere is 5 microgram per meter cube. So it cannot be influenced by wet deposition, dry deposition, or any chemical conversion. When you talk about wet deposition, through rain, the sulfur dioxide cannot be deposited, or through dry deposition, it cannot be deposited, or it won't undergo any chemical conversion, like sulfur dioxide cannot become sulfuric acid. Okay, so that is the second assumption. Third assumption is that any plume impacting the ground is totally reflected. That means plume will not be absorbed by the ground, it will be reflected back. Next assumption is that dispersion does not occur in the downwind direction. It only occurs in the vertical and crosswind direction. Let's understand all these directions. Come back to this figure. Okay, x direction is called downwind direction. That means dispersion will not occur in this direction. It will only occur in y direction and z direction, that is in crosswind direction and in vertical direction. The next assumption is that dispersion is stochastic and is described exactly by a Gaussian distribution. Stochastic means there is some probability, and opposite of stochastic is that deterministic. That means you can determine the things. That is another assumption. Okay. Last assumption is that emission rate are assumed constant and continuous. Suppose the emission rate is 5 meter cube per second, it will remain as it is, and it will be continuous. Before describing further, we need to understand chimney plume characteristics. As you know, this is the stack height. If it will emit some gases, due to exit velocity and buoyancy, gas will rise up. But since there are wind velocity, after some time, gas will start to move downward. Once it will move downward, it will start to diffuse, and once it diffuse, it will take the shape of a Gaussian curve. This is your Gaussian curve. Suppose this is the stack, gas is getting emitted here. Due to wind velocity, it will take the shape of Gaussian curve, and the concentration of the pollutant is high near the stack. As you move further towards left or right, it will start to decrease. So you need to understand three things here. Near the stack, x is 0. Along the plume line, y is 0. And near the ground, z is 0. So since Gaussian curve is a normal curve, you need to understand the normal curve. Under one standard deviation, the total area occupies is 68.3%. 95.5% of the total area are under second standard deviation. 99.75 of the total area corresponding to third standard deviation. So now find Gaussian distribution in the lateral y and z direction. This is the formula. Okay, Gaussian distribution in y direction is equals to 1 by root over 2 pi sigma y exponential minus half bracket में y divided by sigma y whole square bracket in. A similar thing with gz. Okay, since the gas is getting diffused, so we can find the concentration of a gas at any location, and that location is three-dimensional because plume development is always happening in three-dimensional. So concentration of a pollutant at any xyz location can be computed from the following diffusion equation. If you just multiply gy and gz and substitute that in this equation, you will get this entire equation. So you may be asked numerical based on this equation. In the numerical, emission rate will be given, unit velocity will be given. From Pasquill stability class you can determine sigma y, sigma z, and y will be given, z will be given, and it will ask you concentration. So by substituting all these things you can derive the concentration of pollutant. Okay, suppose instead of stack height you will get effective stack height. That means stack height plus height of the gas rise. In that case you can substitute z with z minus h. Why z minus h? You just look at this figure. Suppose you are given with h, so the concentration of the pollutant will be taking into account z minus h. Okay, suppose another scenario arises where reflection occur, so you have to add another term to it, z plus h. Okay, now let's find out ground level concentration. As I told you, at ground level z equals to 0. Just look at this figure. Vertical distance above the ground. Okay, since near the ground vertical distance is 0. So here z is 0, and if h is given, in place of z you can substitute h. Okay, so this is your ground level concentration. Every year in GATE or NET exam you will get at least one question based on this equation, and then you can be asked what is the maximum ground level concentration. As I have already told you, near the stack you will always get maximum concentration, and near the stack and along the plume line y is equal to 0. Just look there, along the plume line y is always 0. So your equation became this. Okay, so how you can be asked numerical? They will give you this q, y, h, and they will ask you concentration. Suppose there are gas emission from landfill side. Suppose solid waste dumping site automatically gets fire, so it will emit some pollutant. So in that case h will be 0 because effective stack height will not be there. So in that case maximum ground level concentration would be c equals to q by pi sigma y sigma z u. Okay, from this is Pasquill stability graph, and from this graph you can calculate sigma y. From this graph you can calculate sigma z.